Welcome to the talk. It's DevSecOps as a Launchpad. Introducing the speakers again. I'm Milind. I'm a cybersecurity engineer. I work in DevSecOps. I worked in application security, working with servers. And this is Akash.
I have a bit of longer introduction than Milind does. I'm actually an electronics engineer with a master's in cybersecurity. I have done a few publications. It's in the space of biomedical, and I've also done some papers on long-range communication systems. While doing that, I got an interest in cybersecurity. I moved into consulting. I did threat hunting, incident response activities, went and pursued my master's. I worked on AI policies, and then I also worked on human-centered design. Post that, I joined Visa, where I'm working in governance, risk, and compliance, external audits, internal audit, control testing. I'm doing automation, working towards getting GRC to GRC 2.0 with all AI and ML activities that are taking place right now. So that's my aim. That's what I'm doing. I also take part in a lot of client assessment, regulatory activities. And I also have started teaching and mentoring a few people. So I went from building communication systems to actually securing them right now.
Thank you. To get started, we don't have a table of contents. We have a table of concepts that we'd like to talk about today. So we'll start with shift left, and then we'll talk a little bit about DevSecOps, what it is, then the challenges that people face, and what kills the developer experience. Because in the end, that is very important, because we work with developers, and if they are not happy, they don't cooperate, they see friction in the process, then it's not that easy to implement security across the whole process, because in the end, they are our consumers. We will talk about SAST, SCA, and DAST to give a basic idea of what they are. Then we will also talk about some regulations that have come up in the past few years. And we will talk about some new concepts like vibe coding. I think everyone is interested in that, and everyone has been seeing it a lot these days. And we will talk about the importance of context. Finally, we will talk about shifting left with that context and how that will help in the new DevSecOps of 2025. Starting with shifting left. Few years ago, when I used to work with people and with new security teams, I would see that a lot of people for smaller companies had waterfall models. They would build, they would test everything, then security would come in, we would give feedback, they would go back to the building step, build it again, shout at us. Whole thing again happens, it's a loop, and people eventually end up hating us. But then Agile came in, where things became a little faster, and people would be able to ship faster, and the whole process kind of got the shift left. I think it's around 2001 when the concept came in. So what they try to do is move the security part from the test before deployment to the develop. And you can see that guy's not happy. That's a security engineer. He's just trying to move things left. And then came the concept of DevSecOps, where we got in automations, we got in pipelines, and Akash can talk about that.
Okay, so I'm going to start off with a question for everybody in the room. Can everybody tell me what DevSecOps is? Anyone? Just a quick one-liner.
Combining all dev, security, and operations.
Correct. That's exactly what it is. So it's nothing but, so it's security practices in development and operations activities. So initially, it was called development operations. It was more around speed, collaboration, and automation. But eventually, that space has evolved, and it is more towards security. So security, a component has been added. It has become a shared responsibility between the security team and the development team and the operations team. So that's why it's called security. It's called DevSecOps right now. So what's happening in this space is every release is getting more secure. Every feature that has been released is also getting more secure. It is making development more quicker, but in a more secure manner. So it's security awareness in every stage. So like Milind was talking about, there are a lot of challenges in this space. The first one that I would like to highlight is called fragmentation. There are so many security tools out there. It could be your SAST tool, your DAST tool, your SCA. What happens is they are part of different parts of the security development lifecycle. It's very difficult to get everything in one particular place. None of these tools are talking to each other. There are issues with interoperability. You have to spend a lot of time configuring them and also training people to maintain and operate some of these tools. As if there's some developers in this room, they would know that many of these tools lead to a lot of vulnerabilities, but not all of them are actually true. It could lead to a lot of false positives. That takes a lot of time to go back and fix and research, and then it turns out to be actually a false positive. The next one, I think this, again, Milind was talking about a feedback loop. It's also delayed feedback from your different SAST. The SAST is fairly quick, but your DAST scans take some time to come back, and the SEA also. So developers have a mindset to go and code, release new features, but when they have vulnerabilities given to them, they have to move away from their day-to-day activities and have to go and research these vulnerabilities and try to fix it. So that's, again, a lot of research time that is spent away from the actual day-to-day development tasks. There are two different mindsets. Developers want to release features, they want to push their applications out, and I don't know if any of your organizations have been talking about it, they want more for less. So they want everything to go out as quickly as possible. But when from a security standpoint of view, they are looking at how secure the code can be. They want to minimize the number of vulnerabilities that exist. So there is a disconnect between the two teams because of different mindsets. There's also a perception, and I'm sure everyone knows about this, that they feel that keeping something secure is going to hinder with the development activities. It's going to slow down my development task completely. So the other point that I was wanting to tell is the lack of awareness of what these vulnerabilities are. So there are two things. I've broken them down into 2 points. There is insufficient instructions of how we should be fixing some of these vulnerabilities. That's when I was actually reading an article which said it could take somewhere between 4 to 8 hours for a developer's time to go and look at vulnerabilities on a very regular basis or a weekly basis. The other is there are very few or none tools that are able to do auto remediation tasks. If that is there, that would make things so much easier. So before we get into the next part of the presentations, I know many of you already know what a SAST, DAST, and SCA tool is, but I want to define each of them, and I'm going to show you a diagram at the end, which compares all the three separately. So the first one is SAST, so Static Application Security Testing. This is, I like to call it the inside-out testing, where you're looking at the code and seeing what vulnerabilities exist. So there are some prerequisites for this. You would have to have access to the code. It can look at common vulnerabilities like your XSS, your SQL injection attacks, but yes, you need to give access to the code. There is one key advantage to this is it can be integrated in your IDEs. It gives quick responses to developers telling them what your vulnerabilities look like, what you need to go and fix. Yeah, so the other part, this is where tasks really helps out, is this is not going to be doing it on your live application, it's just looking at your code. The next one is DAST, that is Dynamic Application Security Testing. This is where it is an outside-in type of approach where you are looking at it as a form of an attacker. It is a black box testing, while SAST was a white box testing. So because it's a black box testing, you do not know much about the application. You do not have access to the source code. You just have an application that's running. So the key difference between the two is you will be able to find runtime vulnerabilities here, while in the SAST, you will not be able to do that. Did I miss anything? OK, I didn't. So software composition analysis. This is another study I read a few days ago. It said about 70 to 80% of all the code that is written is either open source or had third-party dependencies or components present in them. So what SCA does is it looks at open source and third-party components, dependencies, and libraries, and ensures that they are not vulnerable. These components and their versions are compared with CVE, that is Common Vulnerability and Exposures. It looks at the database, it looks and finds out what they're vulnerable to. It also compares what versions exist, are they old, are they new, and tells you to use the most latest version. It has the capability to also look at SBOM. It gives you a comprehensive inventory. What else did I miss? Yeah, and the other part was, this is what modern tools are able to do. So you might have a component that is open source or by a third party that is vulnerable, but are you actually using the code that is vulnerable to? You may not be. You might be losing 2 or 3 parts of that particular component, which is not vulnerable, so you should be fine. So the modern tools are able to discover that for you. So I put everything in a simplified format in a form of a table for everyone to compare very easily. So the first is SAST, DAST, and SEA. The aspects that I've looked at is testing type, code access, SSDLC phase, the primary focus, execution, vulnerabilities found, and implementation. Like I mentioned, the first SAST is going to be white box, DAST is going to be black box, and SEA is component analysis. SAST is the one that requires source code access, and SEA needs analysis to analyze dependency. Yes, it does need access to the code. SDLC process in the secure development lifecycle process. Your SAST is very initial, which is giving constant feedback, while DAST comes in at a later stage. And SEA is throughout the whole development cycle. The execution, that's okay. Yeah, so they can find similar vulnerabilities. The best part about DAST is you can find runtime execution vulnerabilities. And yeah, the complexity for implementation varies from each type. So it could be moderate complexity for SAST, low to moderate for DAST, and SEA is low complexity. How many of you have heard AI way too many times in the last 2 years? Every conference, every politician, every college, I think every industry is talking about AI. And I get calls from my parents that say that, oh, is AI going to take over your jobs and stuff? But I don't know, that's a question. No idea. But yeah, AI is everywhere. They're asking, everyone's discussing it, and we are also going to be discussing it. So, but before I get into AI, right, let's talk about how the regulatory space has changed. And because this is a new chapter in technology, I would say, that is changing so rapidly. Every 6 months, I should not be saying 6 months, even sooner than that, the technology is changing so rapidly. So it's very important to have some sort of regulatory hold over various companies that are developing AI technologies. So I've done a bit of study. Some of them might be directly related. Some might be indirectly related. So that's something to keep in mind when I'm talking about this. So between 2023 to 2025, we have had multiple regulations that have come in. And it could be in cybersecurity. It could be related to data. It could be privacy and AI. So the first one that I want to highlight was US Biden AI EO Act, which was, I think, 14110. This was in late 2023. That was, let's go back. I'll just show. Yeah. So it was late in 2023. That was followed by EU AI Act, which was a beast in itself, which defined a lot of other regulations. So that was pretty good. And then DORA, it's existed from 2022. But it went only into effect in around 2025. It's more about Operation Resilience. And then after that, India also had their DPA Act, which is more about privacy and how reporting works. Recently, Trump's administration had an AI action plan. I think it was back in July that they released it. I do have the dates in the next slides. And also 3 executive orders that were given, that was in 2025. So I think this is some of the regulatory timelines that have shaped this space in the last few years. There are definitely more than what I've written down, but I felt these are important to mention, so I mentioned them here. So the first one that I want to focus on is the US Biden Executive Order 14110. It's more about safety, trustworthiness, and security. It was giving a direction to the Secretary of Commerce and the Director of NIST. This directive was to create policies and procedures for AI systems and people using AI. The other thing is they also had some best practices put in place for red teaming activities. The main push behind this was to adopt a framework called the NIST RMF framework. They wanted to institutionalize that all federal agencies start using that as their baseline. That was one. They also had a notification, direction for notifications for developers who are developing high-risk models and also conducting red teaming activities on them and providing this evidence as part of this particular act. You have to maintain an audit trail for it so that when you get audited later, it's pretty helpful. So that's one. Like I said earlier, it was to push the NIST RMF framework. It also directs a lot of agencies to set up committees and teams to monitor activities around AI. So this was a big push. It was, I think, a 110-page document, which is pretty comprehensive. It is being used quite frequently as well. And it's considered like a North Star in this AI policy. The next one that I want to talk about is European Union Act. This was and is very comprehensive. And when it came, everyone was going crazy because it was so focused on how humans interact with AI. It is anybody who is planning, deploying, and also using AI systems. It was introduced I think in 2024, and it's going into effect in phases, I think till August 2026. It is divided into 4 high-risk items. The first one was unacceptable risk. These are critical risk or threatening risks to safety, livelihood, and rights of people that are getting livelihood of people and rights of people are also considered over here. One example of this I can think of is when you're replacing humans with AI. This is where this particular risk comes into picture. The second one was high-risk systems. High-risk systems are systems that have higher impact towards health, safety, health and safety of people. For example, your critical infrastructure, if it goes down, like your transportation systems, this is something that falls into this particular category. The third one was more about limited. It's more about transparency. It's let people know how these images are generated. So many of the images that you saw in my previous slide are AI generated. Similarly, if you are generating images or videos, you need to ensure that you mention that it is AI generated, which I did not, but I should have. The other one is minimal risk. The other AI systems that exist fall into this category. It could be a spam filters. So that is very low minimal risk. One thing to note is this is more European Union based. So if there's a violation, it could lead to about 3% of your global, I think, profits or global turnover. So it's pretty expensive if you're not compliant to this. The next one is, again, the European Union DORA Act. It's more around operation resilience. I'm going to talk about what its obligations are, but this is impacting more financial companies or infrastructure and also ICTs. That is information and communication technologies that are out there. So what are some of these obligations, right? So the first obligation is towards risk management. So you need to have policies, procedures. You need to have controls in place that manage risk, ensure that you have timely reporting of those taking place in your organization. The second one is incident reporting. So if you identify risks, you need to report them. It could be your authorities, it could be other companies that are in the financial system so that it does not lead to a larger financial impact. The third one was resilience testing. So how I look at resilience testing is you need to have policies that are, say you're doing pen test or red team activities, you need to constantly keep updating the way you are doing your testing. It has to simulate real world examples, and it has to keep changing. So that is resilience testing. The fourth one, which is third parties. So like third party dependencies, third party vulnerabilities, you might be associated with third party, fourth party for various reasons. So you need to ensure that you have contracts in place. But also you need to see if they are DORA compliant. That is another key factor that we look at. Modification of your contracts in such a way that it does not trickle back to you. The fifth one is information sharing. So if you identify any vulnerabilities or malware that are out there that can benefit other financial institutions or communication technologies out there, you need to share it with them. Like I said earlier, it could impact the whole financial system if many of these systems are vulnerable. The next one, India. India also had the DPDPA Act. This is more around privacy and reporting activities. It's mostly protecting privacy of individuals having personal data in India. You have to have notice and consent from people before using their data. It does not mean that you can explicitly tick saying that, yes, you're okay with consuming my data. There has to be an open field allowing them to make that choice. There has to be an option for people to go in, modify their data, and tell you what you can share, what you cannot share with them. So the significant data fiduciaries part is you need to have some sort of a data privacy officer in place who is in charge of data as a whole. The other one was cross-border transactions. I think many of the countries, not just India, is focused on cross-border transactions and isolating their data and keeping them within the same countries. So cross-border transaction is movement of personal information from one country to the other. In this case, yes, they want to restrict the amount of data that is leaving the country. They are also focusing on data localization. Their data remains within their own infrastructures, within their own country. Not just India, but other countries are also doing the same. And yes, if you get breached of some sort, you need to let them know in 72 hours. So this one is quite interesting. It's more of a deregulation than a regulation itself. It is basically pushing towards making that AI infrastructure and AI dominance in the US increases drastically. So this is Trump AI action plan. It was a 25-page document. It came out, I think, in July. Yeah, July of 2023. It also came out with 3 executive orders. I will not go much in detail about these pillars, but I'll just highlight each of them. So the pillar 1 is accelerating innovation. Again, like I said, deregularizing a lot of executive orders that have taken place in the past so that AI investments increase. Building AI infrastructure, same way, pumping more money into AI infrastructure. And the third one was leading in international AI diplomacy and security. So these are a few things. I'm not going much in detail, but let me move on. This is what I mentioned in my first slide is the NIST AI RMF framework. It's like a backbone. It can be mapped to, say, DORA. It can be mapped to your EU AI Act. It has many components to it. The first component is your governance. Then it's your map, your measure, and manage. So governance is policies, who's going to manage it, who is responsible, who are the stakeholders that are going to be. Mapping is more about these are the systems, these are the stakeholders that I have, these are the associated risks, these systems are not associated with any risk. The next one is measuring. So you measure what you have mapped. It could be a quantitative or a qualitative analysis that you can perform on that. And the next is managing. Whatever risk has been identified, who's going to remediate, how is it going to be managed, how quickly it is going to be taken care of. This is what the NIST AI framework does. So I'm going to move on from talking about regulations to something more interesting, which you were very excited about, that is vibe coding. So I'm going to hand it over to Milind.
Okay. Interesting stuff with regulations. Sometimes laws keep up. So, vibe coding, how many of you have heard of it?
You should ask how many people have done it.
How many of you have done it?
Everyone.
So in 2025, a small study was done by a company called Kyodo, and they took around 600 developers from different size companies, and they asked them a few questions. The answers were that 65% of the developers said that they used AI. I think there were more, but people lied. And developers, 44% of them blamed missing context for degraded quality. And 53% of them wanted context improvements. And that is what we'll talk about in a few slides. There are a few challenges with vibe coding actually. So it depends, the quality of code that's generated depends on the type of data the model is trained on. If the data is vulnerable code, the model will give out vulnerable code. If the data is buggy, the model will give out buggy code. Then the dependencies. Sometimes when you wipe code, I don't know if you have noticed, but if your model was last trained in 2024, the dependencies that they add are from 2024, and most of them will have vulnerabilities. And that's understandable. The model doesn't know. It does not have context. Then non-deterministic logic. Generally, when a developer writes code, they generate 10 files in their pull request. With this, they can go up to 80 files in a pull request. And when you see that pull request, you know this is like vibe coded. Half of it is vibe coded. And insufficient human in the loop and governance. Now, when I write something, and before AI, you would do Stack Overflow, you would figure out each and every part of the problem and then write the code around it and solve it. But with this, you give the problem, it writes something, you see it runs and done, you raise a pull request. That is vibe coding. So what's the problem here for us? It's missing context. So let's talk about context. When you look at this, what do you think about that guy who's throwing the water? Bad? What if I tell you there's a fire and he's throwing the water at the fire? Good. But they say don't throw water on electrical fire. That's how context changes the narrative. And the same thing is true for the AI systems. When they don't have context, the way they generate code, the way they answer your questions is from their training data's context, and that will not always be relevant to your problem. So comes in model context protocol. So when all this was happening in 2024, Anthropic realized the problem. They saw the scope of the problem, and they decided they needed to solve it. So around November, they announced model context protocol. Open source, you can use it. All the documentation is online. And they wanted to standardize how AI systems connect to data sources and get that data so that they can gain context from that data. Say, for example, you are trying to build an application, but the AI does not know anything about your consumer or like anything other than what you tell it in that prompt. That comes with context. You can connect it to systems, you can connect it to your documentations, and bring that context to the LLM. And when the LLM is solving the problem, it knows that, okay, this is the reasoning behind it. So good things about MCP, works with any LLM. Anthropic has Claude, great models, but all the other LLMs, we have GPT-5 and a lot of other LLMs, all of them allow MCPs. We can have MCP servers and all those models can utilize those. Then they can auto-discover new tools. So in models, we will get to it. There are things called tools, which allow you to connect to specific data sources. Now, you want to expand. You don't want your context to be limited. Today, it's one document. Tomorrow, is it some report? So you can extend all that, and your models will auto-discover the new tools. And they will maintain the context. Finally, you have to build it once. And all the models everywhere can use it. Most importantly, MCP is not AI. It is, as the name suggests, a protocol. So a lot of people these days think that, okay, you have an MCP server and yeah, the MCP server will have AI and it'll solve the problem, but it is not the case. AI uses the MCP server to get context. There are three main participants in the MCP architecture. So we have the MCP host, we have the server, and we have the client. Host is generally an application which allows the user, so me, to connect to an AI server, MCP server via MCP clients that are also a part of the host. So the host enables a connection between the model and the MCP server. In the end, MCP server is providing the tools, it is providing the context. It is bringing data from other sources to the model. And you can do this in your IDE directly. So how these participants work together? So we see here, we have the MCP host, and we have different servers. It can be your GitHub server, your Postgres server, anything. And now you want to get data from all these into one chatbot window. How do you do that? You have a host. That host has clients which open connections to each server. A handshake is involved. They decide on the protocol specifications. There are 3 right now. So they decide on that. They make a connection. It can be stateful. It can be stateless. And then the conversation happens. We'll not go into a lot of technical details today, but this will allow you to ask questions so that you can figure out that, okay, maybe this can solve my problem, and you'll dig deeper into it. There are some examples of participants. Popular MCP hosts are Cloud Code. If you have not tried it, please do. And Client. Client can sit directly in your IDE and help you connect to other MCP servers and connect with LLMs. And we have a lot of MCP servers. I have given an image for 5, but if you go to the GitHub of Model Context Protocol, I think there are more than 100 servers. Each company is coming out with its own servers, and right here we can see there is something for AWS, there is something for Azure DevOps. So all these will help your models to directly interact with them. So they can make your models consumers and generators as well. How are these servers deployed? They can be local. You can write something, give it to all your developers. Maybe you write in Python, give that code to your developers, they can run it on their systems. Easy, lightweight. The problem is that if you want to add new tools, you have to give the new binaries again to all the developers. Not that scalable. Then comes the remote servers. You build the MCP server, deploy it, and give the URL as a connector to your hosts, and then the host has clients. They maintain connections with the remote server. Very easy to scale. You can add more tools. All your clients will automatically detect the tools. There are few use cases. In security, log analysis is a big use case, because how do you send so many logs? If right now I have a 10 MB log file, a lot of content, I send it to the LLM, most probably it will say that tokens exceeded or context exceeded. With MCP, I can make it like a batch processing system where it consumes a chunk, analyzes it, updates the response somewhere, forgets about it, consumes the second chunk, and we can do log analysis with it. Then you can do audits, AWS, Azure, GCP, you can get data from there. So it's like using APIs, but for the LLMs, you have to teach it a lot of things. In this case, the MCP tools enable all that. The tools have descriptions. The tool tells that this tool is for this specific purpose. The input can be this, the output can be this. It is a string, you can write anything you want. You can tell the LLM instructions of what to do when you get this data. And once the LLM calls the MCP tool, gets the response, it also has instructions that now what to do with it. I gave you a log file, now what? Should I read it? Should I find some specific thing in it? Should I just look for errors? All that context can be passed back from the server as instructions. You can analyze rules. You can audit container security setting. You can integrate with SAST and DAST tools. So this is a basic flow. All this is a developer's IDE, let's say VS Code, right? And they are writing their code. It's a normal day. They have line open, their LLM is there, and they are working with it. They are generating, solving problems. Now, in the old DevSecOps flow, after they are done, they'll raise a pull request. It'll go through the pipeline. SAST will happen, SCA will happen. They will get feedback. And then they have to work on it again. Here, because now we have 3 MCP servers, These can be generator servers and consuming servers. By generator, I mean that they can do scans and get the results back to the IDE in that context directly. So if I am telling it to develop a Java web application, while it writes the code, it will take the code, do a SAST scan, then it will scan my dependencies with the SCA. And now consumer. DAST is not that straightforward. We have to deploy it, and then we can consume the results of the DAST scan directly. And the LLM, because it's already working, it has that context, and the code is open right there, so LLM knows what the whole project is. It can directly consume the results and first not fix it directly, tell you if that is a false positive or not. Sometimes it can give you wrong answers too, but because it has context, because it knows that if you are taking input at one place, in your third file, you have a layer which secures that input. Maybe your SAST scanner did not identify that layer. They look for patterns. LLM can, because it looks for context. It sees how things are working all around. It sees why your function is calling the other function, what data type is going. It tries to observe all those things. And finally, while you're writing, you get all that data, LLM updates your code. So even before you did your commit, you resolved a lot of things. And finally, you do your commit and you push to pipeline. And this is just for one developer. When there are a lot of developers, things, right now, if you see here, all developers, after they have initially worked with the MCP servers, say if initially 100 vulnerabilities would come in, they already did SAST, they already did SCA, they consumed the DAST reports, if they were available. But for SAST and SCA, that was already done. So when that happens again at the end of release or whatever the process is, a lot of those things will not come up because they were already fixed, already taken care of during development, and that is real shifting left. While the developer is writing the code, we are fixing things. Because in the end, developer wants frictionless stuff. If I tell him after a week that, hey, your code has like 5 vulnerabilities, please fix it by tomorrow, he'll be like, tomorrow, Saturday, I'm going home. So with this, while they are writing, everything happens. It's sometimes not that straightforward. Sometimes your reports can be huge. You have to figure out a way to chunk it. And those are like separate problems. But this enables us to reduce the number of vulnerabilities here and bring everything here to the left. One important thing is the reduced feedback loops. If previously we were going through the whole cycle, say 5 times, 3 times, right now, because most of the things are already fixed, we don't need to go back. Maybe by the time they move from here to the pipeline, something was identified in SCA. Okay, fair enough, they have to fix it. But the number of iterations involved is reduced because a lot of things were thought of and taken care of even before the code was committed at the extreme left. Thank you, that's about it. I don't think we are going into more technical stuff with it. But yeah, we are open to questions. Let us know.
Hi, curious how your developers are reacting to having scanning happening within their AI code assistant. Like, have they noticed a change? Did they know it was happening?
So obviously people will see it is happening. But the thing is, when you make the experience seamless, people don't look at it as a separate thing. So when you generate code, initially in 2022, when GPT came out in around December, when it generated code, I was very happy that I just wrote something and it gave me like 100 lines. But today it's normal, right? So for a developer, the attention is not at solving the security thing. Attention is at solving their functionality. They have a feature which they have to build. All their focus is on that. Our intention is to make everything and take it in the background. Developers should not even think about all these things. They should just happen. So that is our whole concept.
At my organization, we actually aren't allowed to use MCP servers. I haven't actually looked into why. I've heard things like MCP is fundamentally difficult to secure, results in poor security. I was curious if you have any insight on those types of comments or mindsets.
So there are MCP has vulnerabilities. It is fairly new, so I'll not say it's perfect. But now the thing is that first you are using it internally, so the risk is a little different. And you build your own server. So if, say, in a host, I have 5 servers, and in my server B, I have an instruction in a tool, and LLM reads everything, right? I have an instruction that whenever someone sends a password somewhere else, send a copy to me, right? So that is how your organization is governing this. And are they allowing that server B to come in? Are they allowing developers to use that? If not, then you reduce your risk again. There are still risks. There is data exposure. There were some, I think, responsible disclosures also by some companies. It all depends on your use case and the scope of the whole thing. And again, building it yourself. Yeah, does that answer your question?
It's helpful.
Yeah.
How do you feel about like your SAST tooling?
How do you feel about your SaaS tooling, like even be able to keep up with the types of problems that developers introduce AI or not?
So things will change. So like if you look at 7 months before, right? Last con.
Yeah.
So most of the talks were that AI cannot identify any vulnerabilities, right? This last con, things have changed. Claude had a research paper out which showed that they can identify stuff. They did red teaming with it. So things are changing. So I think all the tools will have to keep up, and things like I know companies that are coming out with their own MCP servers for SAST, right? That helps. But again, then his question comes in about the risk exposure, because you get like third-party things directly in your IDE where all the code is, all the control is. So yeah, people are keeping up, and with time, I think things will change because the models will improve, and the clients will improve, and the companies, because they also use those models, they will improve too.
Yeah, and things are going to break, so eventually you'll come to know what needs to be fixed. So it kind of helps there, right? So
Yeah, but
I mean, again, managing the risk in certain ways is very important. Yeah, having it internally, internal servers, looking at dependencies, yes, much better. Yeah.
Does that answer your question?
Yeah.
Or did we like go in
Same.
another direction?
I a little bit disagree with it, but I'll
Okay.
just leave it and let's just keep on.
Sure. Disagreement is good, actually. That's how innovations happen. Yes.
Talk about innovation for a second. So this may be a stupid manager question here, but I'm very sensitive to the friction associated with the tools that we provide to the developers. And there's a lot of discussion internally now about using things like WSL for Windows machines to develop and run MCP. And I'm curious if you're seeing people move away or to a different pattern for development off of virtual machines, for example, in AWS, to more local development or sandboxing or anything like that. Just any changes that are being driven by the new technology that AI is driving.
That's a great question. I think changes are happening, but right now I don't have a complete answer for this, because there are so many things happening, so many things changing, that I am also not sure what will happen tomorrow, or how the companies right now are doing things, because Monday they do something, Tuesday they identify a risk associated with it, or maybe it's just not like relevant to them, or it did not work. So it's like changes.
So I suspect, based on the presentation, you guys are pretty good at looking out ahead for strategy. So I know you can't say this is the way we should do it, but I would be curious to hear what you think is going to be happening over the next year or two on the development side, as far as how the developers work.
I think the best thing that could happen to reduce friction, like really reduce friction, is to get everything to the IDE. We have talked about shifting left since I think 2001 or 2002, right? When the term was coined, and that was coined for testing. Then security came in. So maybe in a year, what I see, the scanning comes to the IDE, but we also have to think of a lot of other things, because for a developer, experience matters. The IDE should not get slow. Responses should not be slow. If a SAST scan is taking 60 minutes, no developer is waiting for 60 minutes in their IDE. Maybe outside in the pipeline, they wait because they can do other things. But in their IDE, where they are doing the work, if something is taking 60 minutes, no one's waiting. So the technology has to keep up. Things will change, so there are gaps. But we have great people, so people will solve problems. So I just believe in that.
All right, we got time for one more question.
How do you convince developers to use your MCP pipeline to run the scans?
Can you repeat that?
How did you convince developers to use the MCP pipeline to run the scans? Or is it like automatically run?
So that's the thing, right? You don't have to convince them. You just have to integrate it. And the thing is, it's not about the developer triggering something, but while the LLM is generating code, LLM knows that it has to do these things. You can add that to your system prompt, that whenever, like from where your endpoints are coming, that whenever something happens, do these things, these 3 steps, call these 3 tools. And for the LLM, because we have descriptions in plain text that this tool does X, Y, Z, this is the input format, this is the output format, and this is what you should do with it, then that kind of, again, frictionless becomes a part of the process, so developer does not have to worry about it. So that is the whole concept of it, actually.
So basically the pipeline is triggered automatically when developer asks LLM to provide some solution.
We are not at the pipeline yet. We are still in the IDE. There is no commit done.
Yeah, I mean,
The scans. Yes. Yeah.
Nice.
All right. Well, thank you so much, everyone, for coming.
Thank you.
Thank you.